Welcome to my numerical method in Matlab. Today I will show you types of methods that I'll be using in Matlab. So here we are. There are six types of method, which is the incremental, bisection, false position method, graphical method, Newton-Raphson method, and Descartes method. And this is our main, which is where we input what type of method we'll be using. We'll be inputting our initial guess, the approximate guess, and more, even the equation. So this is how we run our graph method. This is how we run our graph method. Our graph method, this is our graph method and its function. This is where the table of iteration display and the formula for the formula function of the graphical method. And below here is the graph, the GUI graph of the graphical method. So let's start with graphical method. Run the form x exponent 2 minus 4. So here there's six available methods that we'll be choosing graphical. Start interval of 0, 5. As you can see, it display the root of the graphical method. And the root detected here is 1.9995. Now let's move on to the incremental method. Let's create a command. Incremental method. Here is the table of our incremental method. The formula we'll be using here. Now, below, here is the display of the graph of the incremental method. So let's run again our form. So let's use another equation for our incremental method, which x2 minus 3. You can see it calculates all the way till it finds the root. And here is the incremental root of the equation that we give, and the root is 1.7325. Next is the bisection method. The bisection method is where we input the max. We included the max iteration for this method, and then here is the formula that will be used. And below here is the iteration table for the bisection method. So let's run and test. Let's clear first. Run the port get. Okay. So for bisection, we'll be using x3 minus x minus 2. using the bisection level of 0, of 8, step side of 0.05, tolerance will be 20, let's say around 100. You can see is the root of the bisection method and only reached to 25. Confound, even if we put in math iteration, but it limits as where the root is found. Now we'll move on to the postposition method. Now after the bisection method, let's move on to the postposition, which is our postposition method, where the display of the postposition step of iteration table, and here's the initial root calculation. So let's run the postposition method, starting with the simple equation of x over 3 minus x minus 4, 1, 2, say 15. To see, here's the station table, the approximate root. Next up is the second method. Let's clear this up. Second method is the iteration table of the second method, the formula that we'll be using to find the root, and below is the graph, GUI graph. So let's run and test. So let's try cos x minus x. So second approximate, oh, 1, 2, 6. Next iteration of, let's say 8. So here it displays the root. The approximate root is 0.7391. Here there's the iteration table. And lastly, let's move on to the Newton-Raphson. Newton-Raphson, let's create a table. Command window first. So here's the Newton-Raphson. Here's the iteration table of the Newton-Raphson. And this is the formula that we'll be using for the iteration table. And below is the GUI for the graph. So let's calculate the simple equation for the Newton-Raphson method. So x3 minus 2x minus 5 Newton initial gas of 2. So here is the approximate root within 30 iteration for the Newton-Raphson approximation. That is all for today. Thank you for watching, and I hope you enjoyed my video.